Good morning everyone, and welcome back to CNC Techniques in our tutorial about turning and, in this particular case, using the Fanuc manual guide. Today, I would like to introduce the use of both external contouring and pocket hollowing, using only and exclusively the eSoftGate manual guide. We will still talk about predefined shapes, so standard shapes which can be hexagons, squares, circles, rectangles, basically shapes with a predefined geometric form. We won't be making stars or chambers, we'll be doing things that we find standardized within the manual guide, although it's worth noting that chambers can also be made. So, let's start, as usual, with loading the raw material. Today we'll be using our 3-axis lathe, just like a milling machine. So, as always, let's first create a new program, 001. To begin with, inside the program, the very first important step is to carefully insert a comment. Therefore, as always in the edit list, we should proceed to add a comment. Contour testing, MG manual guide. Following this, we will proceed to insert our raw material. We have the option to input the raw material either from a turning soft key or from a milling soft key. It does not make much difference. For instance, let us take a cylinder, modify it, and set an outer diameter of 200 and a length of 50, so that the graphics will be more consistent. We are not concerned with the excess material because we are working on contouring. After that, we either use a fixed format or, alternatively, we can manually enable the C axis, G28, H0, and reset it. These are the two ISO codes that enable the axis and reset it. After that, what do I want to do at this point? I want to make a hexagon head, so I will need a spark plug cutter that faces the self-centering chuck. Let's go to the offsets page, which I have properly modified. So, I need a mill in position 2, here it is, so offset 26, and let's also give it a mill diameter of 26 with a radius of 0. Since this mill doesn't exist, let's take a mill with a radius of 10, which gives us a diameter of 20. Virtual 0.0 is just fine. Let's close 26. So T, position turret, it doesn't really matter, but offset 26. So since we have 26 in position 6, let's indicate that we're using a candle mill with a diameter of 20. So since we have 26, position 6, and let's precisely indicate that we're using a candle mill with a diameter of 20. To begin, we will carefully and efficiently start spinning this mill. So we will use the commands G97 S1000 M13. And in addition, we will also set it to operate in millimeters per minute. Alright, now let's work on the fixed formats. What do I want to do? I want to make hexagon. Here it is. Here we have all our possible milling operations. We're interested in contouring the outer wall, roughing, which often also corresponds to finishing depending on what we want to do. Let's indicate it. So we need to enter all the machining parameters, overlay it on the bottom. This is a translation error from this simulator. As you can see, the T clearly indicates that T is the depth of our machining. Let's say that the depth of our machining is 15 mm. Side stock. Now, be careful, side stock is quite an important thing. Later on we might do 2 or 3 examples. Let's assume that I currently have a raw piece with a diameter of 200 and I want to create a hexagon inscribed in a circle with a radius of 150. This means that between the side of the hexagon and the outer diameter there will be just over 25 millimeters. So the stock to be removed is 25 meter radial cutting depth. Let's make passes. We have a 20 meter end mill. We could make passes of 20 meter, but let's do them at 15 meter axial cutting depth. How much do we remove with each pass? Stock, we need to remove 15 millimeters. Let's split it into 2 passes, 7.5 millimeter each. Finishing stock. To finish this milling later with another tool, or to do it all in one go. To contour it for finishing, set to 1 millimeter. If we don't want to contour it, set to 100 or even 1 micron as already preset. In one go. If we then want to outline it in finishing, then we put a millimeter on it. If we don't want to outline it, we can also put just 1/100th, a single micron as already preset. The same goes for the bottom stock. Feed rate is 500 millimeters per minute. The feed rate when I enter from the solid, so here when I'm just contouring, and here when I enter from the solid. In this case we can set it the same. The specific approach speed for the first adjustment cannot be changed. If we want to work in discordance or in concordance, we work in concordance. Safety distance. In the axial direction, well, I first approach to Z5, so we set it to C5. Type of approach. How do I want to enter? I want to enter directly vertically. I want to enter tangentially to the work direction. I want to enter in an arc. These are choices. I want to enter vertically. And I want to set an approach distance of 5 millimeters here as well. And I want to move away, but I want to move away properly by 50 meters. I insert, but I haven't talked about the figure yet. It automatically takes me to the figures. What do I want to do? I want to create a convex polygon. So a polygon that will be contoured, hence convex base position. I want to work concerning the Z0, so B goes to 0. We set the height and depth 15 meters. It tells me, you see, specify if it's more or less, so minus 15. HA center concerning the X of my hexagon. Hexagon centered on C-axis 6. In this case, I want to work exactly in the center with respect to the C-axis. So, here too, I want to work in the center of angle number 6. We provide the radius, side length, or distance between sides using a radius of 150 meters with a 0-degree angle. For the edge, add a 1mm fillet to round it, to prevent alarms. I'll add an M30 and simulate machining. Rotate. The error is here. Focus on our figure. Given the edge of the component, I want it to have a fillet of 1 millimeter, which means that the edge is rounded off smoothly to prevent sharpness and ensure safety during handling. Just to be safe and avoid any potential issues, I'm going to add an M30 command, which is a standard procedure to ensure the machine doesn't trigger an alarm unexpectedly. After that, I'm going to simulate my machining process to verify everything is set up correctly. Great. Let's rotate the view to inspect the model, and the error is located right here, which needs to be addressed. Now, let's focus on our figure in more detail. Okay, for the polygon's radius, I set the diameter to 75 millimeters, which is crucial for fitting the design specifications. I'll send that information to the machine and make the necessary modification to ensure accuracy and precision in the final output. Let's focus on our figure. Okay, for the polygon's radius, I set the part diameter to 75. I'm sending that and making the modification. Simulate, restart, and start. Here our hexagon is taking shape. Do you see this overcut that I've left here? Now let me explain the situation to you properly. Let's make him hope. You see him roughing out a wall and then moving on. And it finished the machining, but there's too much overcut left on the edge. Let me explain why that is right away. Let's go to our machining cycle. Modify the lateral overcut. I indicated too much overcut and too little lateral overcut. I miscalculated. 35 input. Do you see how fast the modification is? Indeed, it is very fast and efficient. It's quite impressive, isn't it? Simulate, start, and start. This is the S is. The S is the excess metal between this point and the outermost point, and it is important. Fortunately, the graphics help us out and allow us to see and understand our mistakes right away. This feature is incredibly useful as it provides immediate feedback, allowing us to quickly identify and correct any errors we make. Now, let's make a deliberate mistake. So let's go back to our modify soft key, modify the cycle, and set it to S5. By doing this, we can ensure that our work is accurate and efficient. Modify. Let's go ahead and execute. Simulate. At this point, the machine will enter from the solid without removing the overcut. Why is that? Because she simply expects 5 in of excess metal that can easily be removed from the diameter of the cutter and will only make a channel for me. Obviously, this would lead to a machining error. I wanted to specify the S because initially, when I started using the manual guide, I had a hard time grasping it. Now, let's make some other modifications, which are these. Let's go back to the modify cycle and fix our S. 45, let's exaggerate, modify. You can also save these as a subprogram. Why is that? Because if you modify the shape and tell it angle 5 instead, angle number You modified it in a rush without doing too many calculations. Your little project. You see, it's no longer a hexagon, but a pentagon. This is the strength of the manual guide. So when you have a predefined contouring cycle, you could also save it in a subprogram to modify it on the fly. Then you'll quickly learn that 5R is the number of sides, L is the depth, L is the depth. You also learn to read the manual guide. It's not as difficult as it might seem at first glance. Now let's proceed to the next step, which involves carefully inserting a pocket into the garment. This requires precision and attention to detail. Let's grab another cutter. Let's take the TO727. Let's see how it is. So let's go into the offsets for 27. What do we have on 27? On 27, we always have a cutter, and we've always directed it towards the spindle. Let's grab a slightly smaller cutter. So, a diameter of 8. Close it. And when we say T0727, please, candle holder of 8 pieces. Let's keep these parameters optimal, so let's just focus on the cycle. We essentially want to create. So we go back to the milling soft keys. It's no longer a contouring operation, but a pocketing operation, which is important. Let's select the roughing. So, T, depth at the bottom. The same discussion as before. It's a mistake. So when we set our actual depth, I want to make a pocket that's 10 mm deep. As for the SU type, it doesn't show anything. This is because for a pocket, we assume that if it's roughing, it's full. So for the radial cutting depth, the end mill has a diameter of 8 mm. Let's start by giving it 4, which is half of the diameter. Axial cutting depth. If we give it, for example, 4, it will make 2 passes at 4 mm and the last one at 2 mm. It's almost like a finishing pass with the same tool. Finishing overcut. We just open it, that's it. Overcut at the bottom. Ascent, and also here. Advancement. Here we will surely enter from the full, so we give it 500 as regards the advancement, which only engages a part of the grip, and 400. It's not adjustable. I thought it was adjustable, so we set it the same. It's not adjustable. And for the entry, we give it a more cautious feed rate. Here too, we work in harmony, with a radial safety distance of 2 meters and an axial safety distance of 5 meters. We're approaching in 3 axes. How do we want to enter? Do we want to enter at a 45-degree angle or with a helix? If we enter with a helix, we need to give it an entry angle and a helix radius. That must be at least greater than the radius of the end mill. Otherwise, I assume it will be a mess. Let's set it to 6 in this case, and let's say the pitch of our helix is 1 millimeter. Now we insert and go to create a concave circle. Here it is. It should be concave, relative to Z0, 10 millimeter deep. The position is precisely located in the radius of the x-axis, and we have set it to a value of 10 units for optimal performance. So we do it off-center with the c-axis position at 0. So off-center, let's set the radius to 20. Pay close attention to this specific axis, located precisely at the center of the radius. It is important to note that it is off-center by exactly 10 mm on the x-axis, while it remains perfectly centered on the c-axis. Let's carefully insert it in the correct position and proceed to simulate our pocket, followed by everything else that needs to be done. We've successfully created our hexagon, and here it opens our pocket perfectly, just as intended. Now, without repeating the entire cycle, I want to create another pocket, but this time it should be off-center by 10 mm. So let's go ahead, copy the existing setup, and position ourselves at the end to paste it accurately. This will ensure that the new pocket is created with precision and aligns with our design specifications. What are we going to change? Let's change to 10. We can do it from here, so let's modify set x to 10, resimulate. It reopens the previous pocket and starts the new one. Let's modify and resimulate everything. You see that it reopens the previous pocket, and now it starts to open the other pocket perfectly. Now, as you can clearly see, we can open as many pockets as we want, both off-center and centered. So, if we want to open and delete everything and open another pocket, we just go here, cycle through, and we've created a polygon pocket, which is exactly what we had before. Instead of using a radius of 75, we write a radius of 60. In this specific case, essentially. Indeed, so to speak. Very precisely, accurately, undoubtedly, without a doubt, unequivocally. Enter insert, and let's try to execute it. So single, restart, start. It becomes effortlessly and straightforwardly easy to play with contour shapes using the comprehensive manual guide, because once you understand and comprehend how to skillfully manipulate and adjust our data entry tables, it's the same for everyone. As you saw, hexagons or circles are made in exactly the same manner. Now he's beginning to open up a hexagon, first working where the pockets have already been made. A pentagon, carefully and thoroughly, and completely removing the material while always following the previous operational cycle. So approximately 4 mm deep. In the preceding instructional tutorial, we saw how to insert turning cycles. We have seen how to insert both frontal and radial drilling. Now we've seen how to insert standard shapes like pentagons, hexagons, squares, circles, ovals, and so on. These figures can also be drawn directly in manual guide, just like we drew the turning. We'll see that in the next tutorial. I hope you found it interesting. and that you're starting to understand the potential of this strange manual guide that seems difficult but isn't, and that will allow you to start working in a very, very advanced way. Complex pieces, difficult pieces, pieces that the market now demands because we Italians can no longer afford to make bolts and washers. If you liked it, give it a like, subscribe to the channel, and share this nice video on your social media. I say it's a nice video because I made it. Of course it's beautiful. If you didn't like it, just pretend you didn't see it. I thank you for your attention, and I look forward to seeing you next time. In the meantime, I want to include some programs I've made in a commented format. Stay tuned and you'll see them. Have a great day. Thank you all.